Hey, you guys, I hope everyone is having a great day. Today we're going to talk about unit rates and proportional relationships. All right, so this very first problem says a gas pump dispensed 2/3 of a gallon in 3 minutes. The question is, what is the unit rate in gallons per minute? So anytime you see the word unit or the phrase unit rate, that means how much for one, okay? So you have to pay attention to the order of these words because that is the order that you're going to write your numbers. So since it says gallons per minute, we're going to take our gallons, which is 2/3 of a gallon, and we're going to put it over how many minutes? Well, there's 3. Well, that looks a little scary when we have a fraction within a fraction. And actually, that's called a complex fraction, but really it's only a division problem. So really what we're doing is we are dividing 2/3 of a gallon by 3 minutes. And to divide fractions, we are going to keep it, change it, flip it. So we multiply straight across and we get 2/9. So 2/9 what? 2/9 of a gallon per minute. And that's the unit rate. That's how much in 1 minute. All right. So a complex fraction is a fraction that contains a fraction in the numerator, the denominator, or in both. Just a little vocabulary there. The Jackson family walked 4/5 of a mile in 4/9 of an hour. What is their unit rate in miles per hour? So miles goes first, hours goes second. So 4/5 of a mile in 4/9 of an hour. So like I said, it looks a little scary, but it's just a division problem. 4/5 divided by 4/9. Since we're dividing fractions, we're going to keep it, change it, flip it. We can divide 4 by 4 and get 1. So the answer is 9/5. We could leave it as 9/5, or we could write it as 1 4/5, or we could even write it as 1.8. 1.8 what? Miles per hour. So that is our unit rate because that's how many miles they walked in 1 hour. Okie dokie. All right, a cheetah can run 330 feet in 4 seconds. It could ask what's the unit rate of how many feet per second, but it doesn't ask that. It asks how fast will the cheetah run in miles per hour. So we have to do some conversions. So the first thing we got to do is turn feet into miles. So we're going to divide feet. If we're talking about 330 feet, well, how many feet are in a mile? Well, 5,280. Think of it as 5 tomatoes. 5 tomatoes. I always have to think of that to remember how many feet are in a mile. And then we have to think about feet, how many seconds are in an hour? Well, there's 60 seconds in a minute, and then there's 60 minutes in an hour. So there's 3,600 seconds in an hour. So we're going to take these two quantities. First of all, we can simplify. We can divide both of these by 10, and we get 33 over 528. And then on the second one, I think we can divide both of those by 4, can't we? Yeah, of course, because 4 goes into 3,600 900 times. All right, so now we have our feet in miles form, and we have our seconds in hour form. So now we're going to find our unit rate. So we're going to divide our first fraction by 1 over 900. So we're going to keep it, change it, flip it. And so when we multiply straight across, what in the world do we get? Let's see. Actually, I'm going to use my better calculator and just put my fraction straight in there. So I'm going to put 33 over 528 times 900. And I get, my calculator tells me the answer is 225 over 4, which is equal to 56 and a fourth, or 56.25 what? 56.25 miles per hour. Imagine that cheetah running as fast as a car, you guys. That's crazy. But that's how you're going to do that problem. So that one's a little more difficult. That one's a little more difficult because we have to do a couple of conversions before we get the final answer, right? I hope you guys understood that. You might have to watch that example more than once. Oh, and I forgot. I had typed the steps for you. All righty. Well, I hope that helps you guys. All right, so let's look at another one like that. An elephant can run 1/4 of a mile in 36 seconds. At this rate, how fast would an elephant run in miles per hour? Well, first of all, 1/4 of a mile, that's already in mile form. I don't think that's the right way to say that. So we're going to have 1/4, but we're not going to divide 1/4 by 36 because once again, it wants per hour. Well, because we did this problem up here, we remember hopefully that there's 3,600 seconds in an hour. So we're going to put 36 seconds over 3,600 seconds. All right, so it's 1/4 divided by, we can divide both of these by 36. This is 1, and this would be 100. So 1/4 divided by 1/100ths. We're going to keep it, change it, flip it. So basically we have 100 over 4. 100 divided by 4 is 25 miles per hour. That's our unit rate. Look at that difference, you guys. I mean, that's pretty fast for an elephant. Are y'all surprised? I'm a little surprised, but a cheetah is going to run more than twice that speed per hour. All right. Now, when you're asked to find the best deal, well, basically you want the most amount of whatever for your money. So for example, if you go to the grocery store, you go down the cereal aisle, what do you notice? There's always a small box, a medium box, and a large box of cereal. Well, 9 times out of 10, if you buy that large box of cereal, you're going to pay more at the cash register, but you're going to pay less for the same cereal per ounce. Okay. And if you go to the grocery store, you guys look at those little tags on, you probably haven't paid attention, but there's little price markers in front of each item. And if you look at those tags, it tells you what the unit price is. So as you get older and you care about saving money, a lot of people, that's how they shop. They want the best deal. They want the most for their money. Okay. That's why people go to Sam's and Costco, because you buy in large quantities, but you're spending a lot less per ounce or per pound than you would be at a regular grocery store. All right, that's your financial advice for the day. So let's see how we're going to do this. So one way to find out how much we're going to pay per ounce is we're going to divide our money by our ounces. You always divide money by whatever the other thing is, by we'll say weight, but of course it's not always weight, right? But the money always goes in the division box. Or since we're using our calculators, we're going to punch in 2.49 first, and we're going to divide it by 7.5, and then we're going to punch in 3.29 first, and we're going to divide it by 9.25. Money always goes first. So let's figure out how much, whatever this is that we're purchasing, how much is the price per ounce. So the first one I get 0.332. Now, of course, we don't write money like this. Usually we round to the nearest penny, but sometimes when you're finding unit rate, you need more than just, to the nearest penny. Sometimes it's very, very, very close. This one's not too close because this is 35, almost 36 cents per ounce. So for the same product, whatever it is, you're actually going to save money per ounce if you buy the one that's $2.49 for 7.5 ounces. All right, and then let's do this one. So we're going to punch in $2.49 first, even though it's written second, money always goes first. And for the second one, we're going to start with our money, divide it by 20. And let's see what our unit rate is. This one's almost 17 cents per ounce. And the second one is, it's the exact same price. Oh, was it? Let's see. Yep. They were both exactly 1.66. I don't know why I wrote a 7 there. Okay, so we want the most for our money. Well, guess what? Even though these cost different prices, they are the same unit rate. Same unit rate. So that's the answer. The first one, we had an answer. We had a winner. Ding, 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 ding. Winner, winner, chicken dinner. But the second one, they are the same price. All right, now we're looking at proportional relationships. So we're switching over. I didn't give this a new heading, but it's proportional relationships. All right, so you guys are going to start graphing points on a coordinate plane when we're talking about, per ticket in this situation or per whatever. You can take that information and you can plot it on a graph, and so that's what we're doing. So you have to pay attention to what the axis is labeled. So this one is the number of tickets purchased, and this one is the cost of purchasing those tickets. So if we go to the zoo, adult tickets cost $3 each. It says graph the total cost of 1 ticket, 2 tickets, and 3 tickets. So if I'm going to the zoo and I buy 1 ticket, I'm gonna pay $15, right? What if I buy 2 tickets? 2 times 15, I'm going to spend $30. What if I buy 3 tickets and I'm going to spend $45? What if I bought 0 tickets? If I bought 0 tickets, how much money would I spend? I wouldn't spend any money, right? So these are all coordinates now, right? So I can graph these. So 0, 0, this is 0, 0 right there. Well, if I buy 1 ticket, I'm going to spend $15. If I buy 2 tickets, I'm going to spend $30. And if I buy 3 tickets, I'm going to spend, whoop, that one disappeared. 2 tickets is 30. 3 tickets is 45. Where are you? All right, and there are my dots. Now, you don't have to always connect your dots, but if I could draw a straight line, do you notice that this would make a straight line? Okay. So that leads us to talking about proportional relationships. So when you have a proportional relationship, 3 things are true. Number 1, when you graph that proportional relationship, you get a straight line. The second thing is that straight line will go through the origin or just touch the origin. And the other thing about proportional relationships is you can find the unit rate whenever x is equal to 1. So when so here's your x-axis right here. When x is equal to 1, the y value gives you the unit rate. So the unit rate in this situation is 3. And I don't even know what it means. It says text messages sent. So for every 1 text message sent, I receive 3 text messages. So that's the unit rate. The unit rate is 3, and I can always find it when I'm looking at a graph. When that's proportional. I'm going to go back to this example. So this is a straight line. This touched 0, 0. And the unit rate was 15. When X is 1, our unit rate was 15, and that's what it said. Every one ticket is $15. So these are both examples of proportional relationships. Okay, so let's look at the next example. It says, which of these is not a proportional relationship? Well, football tickets are $7 each. So if I bought one ticket, I would spend $7. If I bought 2 tickets, I would spend $14. What if I bought 0 tickets? Well, I would spend $0. The second one says a plumber came to Jack's house to fix a leak. The plumber charged $40 as a service fee because he has to drive to your house. That makes sense. And then he charges $35 per hour. Well, what if the plumber stayed for 1 hour? So the amount he would charge you would be $35 per hour. And then he charges every person $40 for a service fee. Well, if he came to our house and he spent 1 hour, we'd have to pay $35 plus $40 for him coming there. So that would be $75. What if he stayed for 2 hours? Well, 2 times 35 is 70, right? No, can I add, you guys? Yeah, 70, and then 70 plus 40 would be what? 7, 8, 9, 10, 11, $110. And let's just pretend that he came to our house and he only would spend less than an hour, not an hour, 0 hours. Well, obviously, if he didn't do any service, he probably wouldn't charge you. But anyway, if I plugged in 0 into this equation, 35 times 0 is 0, but 0 plus 40 is 40. So does this follow all those rules? It does not, because it would not go through 0, 0 on a graph. So this one is not a proportional relationship. All right, let's look at this problem. This one is asking the same thing. Which of these is not proportional? Well, they're both straight lines. But the problem with letter A is it doesn't go through 0, 0. It's a linear equation, which we'll learn more about that next year, but it's not proportional because it does not go through 0, 0 like letter B does. So this one is proportional. It's a straight line. I find my unit rate is 2 when X is 1, Y is 2. This one is a straight line, but it's not proportional because it doesn't go through 0, 0. All right, look at this one. The question is, what is the ratio of white paint to green paint? So you got to go in those orders. Well, I have to look at white paint to green paint. So white paint to green paint. I could use these numbers, white paint to green paint, white paint to green paint, so on and so forth. Well, guess what happens if I simplify all of these? If I wrote them all as fractions, what would they all simplify to? They would all simplify to 2 to 1. 2 quarts white paint to 1 quart green paint. So that's the answer. The ratio in simplest form of white paint to green paint is 3 to 1. And it's because all of those quantities are equal. All right, what about this one? Here we have a proportional relationship because this goes through 0, 0. It's a straight line. So the question is, what is the unit rate of peanuts? Well, whenever X is 1, the Y value tells us our unit rate. So peanuts are, the unit rate is $4 per bag. And I'm getting those words from our 2 axes, right? This is cost, this is bags of peanuts. In this situation, what does 0.00 mean? So we can make our little T chart and we can put these points on there. 0, 0, it goes through 1, 4, it goes through 2, 8, so on and so forth. So what does this specific point mean? Well, it means If I buy 0 bags of peanuts, I spend $0. If I buy, I'm not writing that, but I'm saying it. If I buy 0 bags of peanuts, I spend $0. That's what that means. And then the final question is, how much would 5 bags of peanuts cost? Well, I see 5 here, but we run out of room on our graph. But since we know our unit rate, we know the answer, of course, would be what? Unit rate's 4, so 4 times 5 is 20 bucks. 20 bucks. All right, and then finally this one, it says the ratio of lime juice to sugar is 1 to what? So 4/5 to 1, 2 to 10, 3 to 15. I'm not going to worry about trying to simplify that complex fraction, but I can simplify these, can't I? Wouldn't this be 1 to 5? And this would also be 1 to 5. So the ratio of lime juice to sugar is 1 to 5. And we see that because of these two. And we could do that one too. We could divide 1/5 by 1, and guess what we'd get? 5. Yep. All right, I think that's it. Is that it? Yep, that's it. All right, you guys, I hope that helps you. You guys look over this a couple of times if you need to, and let me know if I can help you guys. Have a great day.